the idea again that you select an empirical paper that provides both data and code and carry out computational and robustness reproduction. What does it mean? Like computational reproduction, you just kind of run the do file they have and check if this do file produces the same figures and tables which are in the article. Okay? This is a kind of computational reproduction. Robustness reproduction, this means that you need to kind of suggest, based on the weaknesses of the paper, what can be improved and really improve this in the do file. For example, you can think, okay, so they do it for the sample of, I don't know, individuals from 16 to 60 years old, but it was a kind of pension reform or something like this, and in reality it would be 65. Or you do some different estimators, but it is outdated, so you can propose some other estimators that improve this. So there are two tasks. First, you duplicate what they do exactly and check if you can also check if the package is complete, because in some cases it can be, there might be some kind of errors in their new. We also, our chair, organize every year replication games when we do it by ourselves. And actually I will upload some kind of example of the replication report which we prepared. And based on this replication report, so this can be an example, and you have to prepare a replication report of yours for this particular paper. So it could be a bit shorter, but it should include like all calculations, robustness check, the do file, and you have to also present it in the final class. Yeah. The good question, where can we take these papers from, right? So the good idea is to look at the journals of American Economic Association, because this journal has a good standards. They provide both the code and the data. All articles published there are required to do this. So, for example, you go to okay, I just typed returns to education just as a kind of idea, and you see there are some papers like signaling and employer learning with instruments, I don't know, estimating marginal returns to education. You see the paper, so you can download the full text PDF of the paper, and you can look here, and there is always a replication package here. Yeah? You see it? And so you click a replication package, and then normally there is a kind of a README file and the entire replication package for this paper available. Or the other paper like signals, again like it's this paper. Yeah. Okay, so there might be some other estimating marginal returns to education. Yeah, you see there is like a README file, which is normally where it describes everything about this replication package, and you can see there are some do files, DTA files, which are data format files, and yeah, and in this README file, document it is stated normally like what is included and how to run it. So this is what you have to do. You can search any paper here which is related to the topic of your interest within economics education. So it might be early childhood education, higher education, education, labor market outcomes, returns to education, so anything you might be interested in. Okay. Is it clear? Any questions on how to do something? No? Yeah?
Yeah, maybe. How much additional literature would we need if we extend the paper and say how much additional literature would we need?
This is, you mean for, not for replication, but for...
No, for replication, or do we really just need to replicate and extend the paper if we use the replication approach?
No, it would be nice if you kind of link both projects, like doesn't matter if it's a replication or if it is your proposal, you link it to somehow to the lecture material. So for example, this paper tests signaling hypothesis formulated in the market signaling theory, and you kind of briefly look at the literature, so to understand like the place of this particular paper in this literature.
Okay.
That's it. So yes, you cannot completely ignore and just replicate the file and that's it. Because if you want to replicate, and if you want to make not only computational but also robustness reproduction, then for robustness you need to understand the context. How do you know what to kind of destroy in this paper to get some other results? And to be able to know, then at least you need to read this paper, and if you read this paper, you can also look at what papers are cited, and normally in this paper, like if you open, I don't know if you can download it, yes you can. So there's an abstract, then, okay, so some kind of theory, you see, Beckers, Pence, then they normally discuss. Yeah, so when you replicate, the idea is that you read the paper, and then, okay, so in the paper you have these results somewhere. Yeah, you see, and so actually the do file have to represent, build all these figures and tables. You need to check if they are actually produced or not, or maybe they are somehow different. Yeah, and normally there is always kind of short review of literature in the paper, yeah, and they also tend to state their contribution, and it is important that you at least kind of read briefly this literature and understand the contribution. So you see, for the second extension, we release the assumption about homogeneous returns. Recent studies has provided evidence that returns can vary across individuals. So, and you can, for example, kind of look at this paper as well and see what the contribution of this paper compared to the previous one. Yeah. So. But of course, in your research project, if it's a research project, then you have to do much more. Like you have to really read the literature on, like, if you study the effect of student employment on wages, you really need to know this literature. You need to provide some literature review. For this particular, for replication or reproduction, you have to kind of understand where this paper is placed in the literature, how it contributes to the literature, and how it is related to the theory, which we discussed in the lecture, and that's it. So it's a bit less work with the literature, more work with do files. For your project, it's a bit more work with the literature and data, and less work with the do files. Okay? Seems like clear. Yeah? Okay. Then we move to the second part of today's class. You have to open Blackboard, and in this Blackboard folder, there is a folder seminars, then seminar 4, and then you can download all the files from here. Yeah, we have a seminar 4 task. This file provides a task for our today's seminar, and there is a short do file and data sets. So the most important is seminar4.dta. If you already downloaded SWAP dataset from the previous seminar, you don't have to download it again because it's already on your computers. Probably this is the same data as we had in the previous seminar. Okay. Please let me know when you are done with the download. This you already downloaded?
Yeah.
Yeah, everyone downloaded. Okay, so we have two data sets. I would probably suggest the following. We start with the data set, problem set 2, and then you will try to do problem set 1 on your own. Okay, problem set 2 is more difficult. To work with the problem set 2, you need to use this file Draka 2011. It is here, seminar for PTA. And you can look here for the problem set. Did you have lecture on difference last week or today?
Yeah, as we
Last week.
different.
Yeah, and RGB was today. So today we have a seminar on difference, and so in this problem set 2, the idea is that we use the data set from this Draka file, which examines the impact of the UK minimum wage on firm level average wages and profitability. And so the idea is that in the United Kingdom, there was a reform which introduced on April 1st, 1999, a new minimum wage, and there were some other changes of the minimum wage during this time. And actually, firms who pay low average wages before 1999 are the treatment group. So actually, it's quite expected that mostly affected by the minimum wage changes are the firms which pay low wages. Right? So if your firm tends to have many workers for whom they pay low wages, then if some changes in minimum wage legislation are implemented, then probably your firm is becoming a treatment, and for the firms which do not pay low wages in general, they are the control group. And so these guys, they classified the firms as low or normally paying firms, and analyzed the effect of this introduction of minimum wages. Okay? So we can just describe first the data set. And so you can see we have several main variables. So we have ID, which is a company ID, year, specific year, and then like most important are variable low, which takes value 1 if it was a low wage firm in 1999, and we have a variable cost, which is equal to 1 after the introduction of minimum wages. And we have two outcomes of reform net profits and logarithm of average firm wages. And we have some other control variables here. Okay. So then task 1, we should identify the treatment and control group, and then inspect the trends in average wages and profits across these groups graphically over time and interpret the findings. And there is a kind of help here that you can use a collapse command to obtain group averages over time. We are interested in average wages and average profits across treatment and control groups. To plot the means over time, you can use a two-way command, and then kind of this type of synthesis. So you have a line, then your y variable. Y variable is your outcome. It's either wages or profits. Then x variables, and then if value, if and some condition, which should be included. So if we do it together, we can first ask Stata to preserve the data, because for the collapse command, data will collapse all the firms, it will destroy all the data we had previously, and just will collapse the data based on average wages of the firms and average profits afterwards. So we can run this collapse ln wage by and then two indicators. If the firm is low paid or high paid, and then year, and then we kind of two-way. This is a common for building a figure in data, and then there is one line ln average wage year if low is 0, which means that the firm is a high wage, and if low is 1, which means that the firm is low wage. And we can after that restore, which means that data restore the previous version of the data file. So let's run it and see what happens. Okay, so it produces a nice figure. Yeah. So as we discussed, the reform was carried out in 1999, like after 1999. So this is a period before. You see, almost nothing happens here. There are differences, of course, in wages between high wages and low wages firms. Yeah. But you can see that after 1999, there is an increase in the wages in both groups of the firm. But in the low wage firm, the increase is much stronger. Yeah. And it's quite logical because you impose new minimum wage legislation. This means that minimum wages are increased, and this means that for low wage firms, there is an increase in the average wages they pay to their employees because they have to comply with this legislation. Yeah. And then we can do the same also with the profits. So what happened to the profits of the firms in this time frame? So it also doesn't seem very surprising. Yeah. Does it work for you? Yeah. So again, like we have low wage firms and high wage firms, and we see that for low wage firms, there is a considerable decrease in profitability after 1999. Which is also very logical because if you make firms introduce the minimum wages, so their costs increase, and as a result, their profitability really decreases. Yeah. Yeah, it's clear. Okay. Yeah, so you see, these are the trends in the net profits and in wages for the two groups of the firms across time. So low wage firms are our treatment group, and high wage firms are control group. Okay. Then task 2. This is a key one. So actually, they ask you to estimate the effect of the minimum wage on wages and firm profitability using a standard differences approach based on the cost as well as a treatment indicator without any additional control variables, and then interpret your findings. So this is the main and easiest thing you can do when you have to do a difference in difference method. So you have two outcome variables. One outcome variable is the lowest of average wages. Other variable is net profits. Yeah, and then you include two dummy variables. First dummy variable is cost, which means that this is the after period, and the second is low, which means that this is the type of firms. So the idea with difference in difference difference is that you analyze the differences between the treatment and control group over time. So let's try run them together and think how we can interpret it. Okay. Do you know what is this double hashtag? No? This is actually, it asks data to estimate the model where you have post low and post times low. So it is interaction term. I can run, so for example, I can generate post low, which means this is a salary in post period for low paid groups, which will be post times low, for example. And then I can regress the same by net profit, then post low and post low. Yeah. And the result will be completely the same. Okay. Can you see it well? Not really? Or no?
No, it looks.
Like this. No, there's definitely a way how to do it, but I totally forgot because I don't really use it. Is it better or not?
Yeah.
Yeah? Okay. So this is a first regression with the average wage, and then you have three coefficients like cost, low, and cost times low. From the regression, from the lecture, do you remember which of these coefficients might be interpreted as a difference in difference estimator? Okay. Yeah, you can see difference in difference estimator can be obtained from a single regression. So you have after, which is like for after period. You have a treatment group, which is for your treatment, and then you have a coefficient for after times treatment group, which means what happens to the group which was affected by the reform after the reform. Yeah? So this coefficient is your difference in difference estimator. Yeah? You have after period which captures common time trend. You have beta 1 coefficient which captures differences between the groups before the treatment, and you have this coefficient which captures the difference in difference effect. So this is the effect for the treatment group in the after period. Yeah, this is the main idea. And if you look at the Stata file, yeah, what is our treatment group here? So we introduce the minimum wages, and it might affect firms differently. There are two types of firms. What is the treatment group?
Okay. firms that pay below the minimum wage?
Yeah. So the treatment group is low, which is so if you tabulate or describe, for example, describe low. So it was a low wage firm in 1999 before the reform was implemented, right? So if you calculate, you will see that in the sample there are 974 firms, like 24% of firms which are low wage firms, and 76% are normal wage firms, high wage firms. We already draw the figures for these two types of firms. So again, if we look here, what is our treatment group? As you mentioned, this is a low paid firm, right? So this is this low group, right? And then we have two periods, like before the reform and after the reform. Before or after the reform is captured by the coefficient post. Yeah, post treatment. So we have the post, and then we have a low. And we have a post times low, which is the effect after the reform for low paid firms. And so this post times low is our difference in difference estimator, which captures the effect of the reform. Yeah. So from this coefficient of 0.11, you can kind of assume that the reform increased the wages in low-paying firms by 11%. Yeah. How can we interpret these two coefficients for the post and for the low? Yes.
Yeah, that's the treatment effect. No, that's the change not related to our treatment or no treatment for the low and the high
Which one?
firms.
Post or low? Or both of them? Okay, post means that like this is a dummy variable for the period before the treatment or after the treatment. And low is a dummy variable for low paying firms versus high paying firms. So how would you interpret these two coefficients then? No ideas?
I mean, the low is then before the reform, so that the low.
No, low is for the types of firm.
Yeah, but it describes just being the low, but without respecting the reform, doesn't it?
Yes.
Yeah.
It's pre-reform period.
Yeah.
So actually this low coefficient, it captures the difference between low and high paying firms in the pre-reform period, a kind of initial differences between the groups. So, and it's quite, again, logical that in low paying firms, the wages are 62% lower than in high paying firms, right? It's not 62%, it's like approximately, I would say it's approximation, it would be like 85%, right? So that, and for the post period, this post dummy, it captures the time trend, which is common for both groups. So, because even without this treatment, maybe there might be some kind of, due to inflation or something else, there might be increase in the average wages. So this 0.11, it captures the effect, the common time trend. So First coefficient is a common time trend for both groups. Second coefficient is the coefficient for comparing the wages between the groups in before period. And this is the most important coefficient, cost times low, which is a coefficient what happens in the treatment group after the reform. And so as a result of this estimation, we can conclude that as a result of the reform, there was an 11% increase in wages in low-paying firms. So this is a treatment effect for this group. Yeah. It's called also ATT, average treatment effect on the treaty. And we do the same with the net profits. Okay, could you please help me with the interpretation again for net profits? What's the effect of the reform on the net profits?
It decreases the net profits, right?
Decrease the profits, yeah, in the low-paying firms.
That's it.
Yeah?
Yes.
By 2.7%.
No, by
2.7 units.
sorry. Yeah, that's it.
Yeah. Okay, and so for two other coefficients, again, like we have a common time trend, which is captured by this post coefficient. So the net profits in all firms decreased during the observed period, right? In period T+1 compared to period compared to the period T, there is a decrease in the net profits for all the firms. And we also see that initially, before the reform, low-paying firms were more profitable than high-paying firms. So this is how we can interpret this coefficient. But we are mostly interested in this post-low coefficient of minus 0.0273, etc. So this is interpreted as a difference in difference coefficient. Any questions on that? This is the easiest part. No? Okay. Then we have
could you,
a bit more.
Could you explain again
Yeah.
the last few sentences?
Regarding the what? Regarding the groups?
Yeah.
I wish I had a. Again, so we have here three coefficients: post, low, and post times low. Post captures the time effects for both groups. It means that what happens after in after period compared to before period, regardless of the group. Yeah. Then low captures the differences, initial differences between the groups before the reform. And then we have cost times rho, which captures the differences, for the treatment group in the after period. So if we return to the lecture terminology, yeah, we have two groups, like treatment and control, and we have a before and after period. And so the idea with difference in difference estimator is that it compares the differences between the groups in the period after and before. And so actually by including in the regression these three components, after treatment group and after times treatment group, we can do this estimation. And again, like after coefficient, it captures the common time trend for each group. Treatment group coefficient captures the differences between treatment and control group before the treatment. And after times T group captures the differences for the treatment group in the after reform period. Yes.
Is that possible that the time for after and before the the position reversed, for example, like is that the after time certain defined as after before, or is that possible that both kind of time point to change?
Sorry, I think I didn't get the question.
Is that possible that change the time point, and it is to say like before treatment, after treatment, but for example, like if the treatment haven't happened yet and they already say that after treatment and they have, is that possible to include some errors in it, or
No,
is
but
that
if treatment has not yet
happened,
then
but
you
they say
cannot
that
estimate anything because you
yeah,
you
right,
don't
but
have the
but it
difference
is that possible that to mix both groups, or it is like only only be defined as haven't some groups haven't got the treatment, but they say that they got the treatment, and they reversed the time point reversed and to say that some errors that's included. And is that the possible case, like when we write the statement on arbeit, and should we just kind of say this kind of error existed actually, and how can we just interpret that?
Yeah, I think it's just super simple. Like we have two periods, before period and after period, and in difference model we kind of estimate the effect in after compared to before, and we compare the effect for both groups as well. But this is a simple model when we have just two periods. Yeah, this is a treatment control before after. It is called 2 times 2 table. But in reality, we might have not just two periods, we might have a lot of periods. But anyways, we kind of classify them together, or like if treatment was carried out in this period or not. So you always have this time line, and this timeline you have to always clarify, like you have two main components. You have to define the control group and the treatment group. So for some group something happened, for other group nothing happened. And then time you might have 10 periods, for example. But these 10 periods can be classified that in first like 6 years nothing happened, and it will be before, and in the next 4 years something happened, that will be after. But there might be also reversal in the treatment. So for example, 4 years is before, then 3 years is after, and then they switch the reform, etc. But then it will be kind of a bit more complicated methods, which are analyzed with advanced studies, which we will also do today in the
So the time point is not important, so to say.
What is not important?
The time point is not important. It's only important that to differentiate the before and after, and
Yeah,
after
exactly.
and before. So it doesn't matter
time
actually.
matters only respective to the event.
Yeah, exactly. Okay,
So
thank you.
something happened, and then if something happened, then it is considered as after, because it happened after something happened. example, have 9 days before the treatment. So for him, it's a before period. In 9 days, he will have a treatment like presentation. Yeah, so be done. Okay, then we can look at the next task. The next task asks, are your results robust to the inclusion of a full set of firm and industry characteristics as covariates? Basically, they ask us to just to add some control variables here. Yeah. Are your results robust to the inclusion of a full set of firm and industry characteristics as covariates? This actually means that they ask us to include, so we have here like a low, post, then two outcome variables, net profit and wages, and then we have a set of control variables. So they ask us to include these control variables and see what happens. So we have the same regression, which initially we had. This regress, L and wage, I post times I low, right? But now we also include the control variable. And so the idea is to see if our results will change or not after the inclusion of control variables. So I run them. This regression with control variables now. You see now we have, as previously, we have these three coefficients which we interpret, but together with these three coefficients, we also have new coefficients. These new coefficients are for each control variables, right? But we don't really care much about these coefficients. We care about our main coefficient, which is our difference in difference estimator. So what happened to our difference in difference estimator compared to the previous case? Can you check this?
It's lower.
Yeah, it became lower, right? So we had something like 0.11, right? In the basic. Yeah, it was 0.11. And now we have 0.09. Okay, but overall it's not that significant change, right? So okay, our wages in the this group of firms, they increased not by 11 but by 9%. Okay, not that big difference. Okay, and if we look at the net profits, so previously it was minus 0.27. Now it's minus 0.22. Okay, so you see that actually our results are quite robust to the inclusion of control variables because they don't really change that strong. Yeah, so we had 11, now 9%, and 2.7, 2.2. So overall, in this case, our specifications are robust to the inclusion of control variables. So we can conclude that actually the reform positively affected wages, but negatively affected firm profitability, right? Which is very also logical, because if you ask the firms to increase wages to their workers, then their profit is decreased because their costs rise. Yeah. So. Is it clear?
Mm-hmm.
Yeah, so the results are robust. Then the next is to...
This could also be like a possible extension for our work by adding different control variables. If we, example, choose a replication package with a difference in difference,
Of
then we
course.
could, for example, add more controls and see if the ATT changes.
Yeah, very good suggestion. Yes, you can include if you have them in the data set.
Yeah.
But yes, it's really nice. The easiest, actually, the
Yeah,
easiest thing you
I
can
was
do.
thinking about this.
Yeah, exactly. So you can either change the specification of the model or the model. It's always easier, okay, to say that, okay, maybe they didn't look at some, I don't know what, differences in returns to education between like self-funded students or I don't know, students with some stipend. And so if you can solve for that, then change. Yeah, it's a good idea. Then again, okay, the next question, what are your expectations about possible patterns of effect heterogeneity regarding the profits when comparing manufacturing and other modes? What are your expectations, by the way? What do you know about manufacturing and non-manufacturing sectors? In which sectors it is more likely that there will be low-paid workers? Yes.
I think it's manufacturing, and if it is talk in the range of in Germany,
In manufacturing, more low-paid workers.
high paid workers
High-paid
than
workers,
the
yeah.
other branches.
Yeah, so normally in manufacturing we have more high-paid workers, and in, like, for example, in services or tourism, we might have a lot of workers who get minimum wages. Also in some, like McDonald's, people work with the minimum wages. Yeah, so, or in some other services, it's quite often that people work with minimum wages. And so then our expectations would be that there might be some kind of effect heterogeneity depending if the firm works in the manufacturing sector or not, right? And so to check that, we can also rerun our regressions, but do it for manufacturing and non-manufacturing sectors and check if results will differ, for example, for the profits. So do they differ? Yes?
Not really.
Not really. How do you define?
I think that they are more homogenized.
Homogeneous?
Yeah.
Okay, how we define together? What's the coefficient for the like manufacturing sector?
Because the correlated error was not was not the error was not correlated. So
Yeah, but let's look at the coefficients, right? So again, what's the
like so smaller than 0.225, 25.
25?
Then smaller than 0.2225. That's why it's that insignificant. That's why it's homogeneous.
That's not the correct answer, actually.
Ah, okay.
Let's. Yeah.
Let's say is different. If we pay attention to the confidence intervals, we see that they are not included, right? Like the first one.
Yeah.
That's
So-
the answer.
Okay, so we have a first cost flow. The effect is negative, right? This is for non-manufacturing, right? Because manufacturing is zero. Here you can have different things. You can look at p-value, which is like almost zero, which means that the effect is statistically significant. And as you also mentioned, for the confidence interval, it doesn't go to zero. Then it is statistically significant coefficient, right? And if we look at the second group here, we see the p-value, which is very much higher than the 0.05, which means that coefficient is very much not statistically significant. So this means that actually the effect for manufacturing sector is not statistically significant, and the effect for non-manufacturing sector is statistically significant. So we see that the reform negatively affected profits, negatively affected profits in non-manufacturing sector, but doesn't have any effect on the profits in manufacturing sector. So that's the main idea. Yeah. Now, the next task is to run a dynamic difference in difference. Previously, we have a difference in difference just with two time periods, before the treatment and after the treatment. But now we can run a dynamic difference in difference specification using the interaction of here dummies and the treatment indicator. And to do so, we can just regress net profit variable, and then we add instead of post, we include year variable, which is for each year. And so we estimate kind of a dynamic effect of the reform for the manufacturing firms. Yeah. This is what we obtain. And so this is the year times rho. In that case, is a difference estimator for a particular year. And so you can see that it's all not statistically significant. They are all not statistically significant, which means that there is actually no effect if we look at each year. But what is important in difference, it is called parallel trend assumption, which means that we do not expect to have any effect of the reform before it was implemented, right? And so that's why it's important to look at the coefficient before the treatment, like 1998, 1999, to check if there is no effect. So they have to be not statistically significant. For example, in the lecture, I think you have it here, right? So it is very important to, the main assumption of the difference in difference method is that actually in the absence of treatment, the control and the treatment group would evolve similarly. So this means that the effect will not be different that much. Because graphically, difference in difference effect is this difference. So we kind of expect what would have happened with this group without any treatment. We kind of have a common trend, and then we compare it with what really happened. It's what is done by difference in difference method. And what is important, for example, in the event study, graphs, something like here, it is important that before the treatment, so, okay, this is a timeline. Here is like point 0, which is the point where there was a treatment. So this is 1 year, or 1 period, 2 periods, 3 periods, 4 periods after the treatment. This is the period before the treatment. And it is very important that there will be no effect before the treatment. Because if there is some effect before the treatment happens, then we cannot really tell anything about the effect of reform. It is important that there will be no parallel trends here. And actually, to check that, we can test if the coefficients in the before period are statistically significant if they are differ from 0 or not. And so we actually using this F test. In F statistics, we estimate that we cannot reject the hypothesis that these coefficients are equal to 0, which means that we don't have any problem. And on the final stage, also are supposed to add some firm fixed effects in the regression and see what the results are here. So we ask Stata to treat the data as if it is panels and use xtset common for this. We have xtset ID here, and then we run the regression with the control variables, and we see the results we obtain. And actually the results we obtain are very good, because so this is our year times row. This is our difference in difference estimators. In which year the effect is statistically significant of this? At least at 10% level. Do we have any year where it is statistically significant? Yes?
I'm not sure, but 1997?
Which one?
1997
97.
is not included.
It's not included. I mean, which is statistically significant?
Ah, okay. What? Also, here is no years actually.
At 10% level.
Yeah.
Okay, do you remember how to define statistical significance?
Like 2007.
To look at what? The p-value, right?
Yeah,
We
like
compare the
look
p-value
at me.
here, right? We compare the p-value with some significance level here. We can compare it with, for example, with 0.05 if we have 5% significance, or we can compare it as 0.1 if we have 10%. So, as I said, like at 10% level, which coefficient is statistically significant from all these based on the p-values of these? For which year? Yeah, exactly. 2000. Yes, yes. Exactly. So you see, we compare these p-values with set 0.1, and so if it's lower than 0.1, then it's statistically significant. What do we know? The reform was implemented in 1999. Yeah. So the first year after the reform was implemented, the effect is statistically significant, which is good, which is the effect of the reform. And what is also better than in the year before the reform, the effect, there is no effect, it's not statistically significant, which means that the parallel trend assumption holds. So this means that it's super important that before the reform actually took place, there is no effect of reform, right? Okay, any questions on this difference in difference stuff? No questions? Okay, good. Then you can do the second task on your own. Then you have to use a SWAP data set, another data set. It's like here. It's the same data set we use for instrumental variables analysis. And then there is a set of tasks which you have to do. The main idea is that there was a reform which was carried out in North Rhine-Westphalia, where the compulsory schooling was increased by 1 year for all birth cohorts starting from 1973. Also it's important to consider only individuals in the age of 30 to 60 and 2012 year only. And so the question is, was the reform successful? What is the effect of the reform? please let me know when you finish the task one and we can discuss it.
Yeah, very good suggestion.
So did anyone complete task one?
I'm trying, but I cannot see.
You completed.
No, I tried.
Ah,
I
okay.
tried.
Okay.
How come with the like list of states here or something?
You need to tabulate a variable state to see how it is.
Yeah, but can you tabulate? Okay. No.
Have you tabulated it?
Yeah.
Okay. Do you see North Rhine-Westphalia there?
Yes.
Then you can create some kind of variable if your state is number
Yeah.
5, right? So
Okay, because I had written North Rhine-Westphalia, but that's not valid.
no, the state doesn't understand that, so you have to.
Okay.
There should be a number. No, not both sides. No. No, you have again like you have a task, right? Um, so you have to create a dummy variable indicating the state of North Rhine-Westphalia. So this kind of a treatment group. Then you kind of generate a new variable. You have a generate comment to generate get generate, yeah. Yeah. So you generate a new variable, you can call it like treatment or something like that. or T-state, treatment state, which is equal to 0, for example. This is how you do the creation of any variable. And then you replace it with 1 if your state is 5. This is how you
T-state or just state?
T-state is equal to 0, yeah?
Yeah.
No, without it, just think how you create this. You
Yeah.
want some variable which takes a value 0 if no treatment and 1 if treatment. So you create just a 0. You just run it, okay? And then you can replace, replace the variable is equal to 1 if your state is 5.
Okay.
Yeah, so
Okay.
that's the idea. But I will probably start with the first task because they stated that you have to limit your sample to individuals from age of 30 to 60 and also only 2012 year. And so we do it with the comma keep. Replace this state with 1 if state after if we have double
this
equal.
one.
The second one is wrong. Why?
Okay, because
You did everything so bad that now you need to open this data set again. Otherwise it will not. Yeah,
Okay.
you better write with a do file.
Hmm.
Yeah,
Okay.
and this do file you can kind of rerun it again, but now you can just open the new file. And the idea here with this code is correct, except for there should be 2 equal. If state is equal, because after if we use double.
Okay.
5, yeah, exactly. And you?
Yeah.
Not yet?
Yes.
Ah, yes.
This was, I also used
You
the-
did different syntax, but yeah, it's good, it's good, it's good.
I also used the ChatGPT, of course, but it's-
Yeah, it's also fine. It's also fine.
it's when it works. But after the next task, I don't know.
Yeah, let me check. Oh, okay, already here. Yeah. Yeah, cool. Good. Okay, does it work for you? Not really. Okay.
This is a
Where is the problem?
layer of cohort.
Maybe I didn't download the wrong.
Yes, you
right.
use the wrong file.
Yeah.
It's not. It's just socioeconomic panel data.
Oh.
It's other file.
Yeah, but you already did the
Swap. Yeah.
regression.
Okay. And for you?
That's already there, right?
No, you still work with the previous one.
It's this
No, no, you work with the previous one. Now you have to work with the other.
Okay.
Yeah. Socioeconomic panel. How's it going? Okay, you can check yourself. You can just tabulate now the new variable.
And then top and P stage.
Yeah. Okay, very good, right? You see there are 23,000 observations here, and there are the same 33,000 observations here, right? So this means that you created it correctly. Cool. Now create two more. Okay, for the next seminar you should do it by your own, otherwise you will just not. Yeah. So. Uh-huh. No, it's better to work with the codes. So for example, if you, maybe to work, let's see. It's type mismatch because like it's better to use with numbers. So can you tabulate state? Right, tab, and then state. But backspace, yeah? No, just, okay. And state with a small, which you teach it with small letters normally.
Oh, okay. But I have it this one. Out of stage.
Yeah, and now put some space between them. Yeah, okay, tabulate. Yeah, you see now the variable state is coded with 5. Yeah, this means that actually your code was almost correct, but
But I had it here to say far.
okay, so you did it already.
Yeah, but this was before.
Ah,
When
okay.
at the law.
Yeah, but you can just find it here. Click, click,
Here.
and this is yours.
Okay.
But remove this star.
Yeah. But what's the first one? I didn't do it, I think.
What is the function? Yeah, because of course, because you have to remove this double.
No,
This is not related to the code.
That's true.
Can you click again on 17 and remove this and remove? We are getting very close, but still.
So that's the second one, that's the first one.
Yeah. So you just create a new variable which takes value 1 if the state is 5. Yeah. Okay. You can also tabulate this new variable. For example, you can tabulate an array. Tabulate. Without generate, just tabulate it. Yeah. Tabulate, then another, okay. Yeah, you see, this is the number of observations in the North Rhine-Westphalia, right? So you can go up a bit and check how many observations you have. This exactly. This means that your variable is created correctly. Yeah. Good. So did you manage to create a variable for years?
Not wrong. Was it something like this?
Okay.
12 point.
Something is wrong.
Yeah.
Yeah,
Because it's not
because
the same way.
not just 1 year. You need people who were born after or before. What is it? After or before? I don't remember.
I think after.
After. Which means that it should be more. Yeah, very good. Everything except for a year. It should be more or equal and not equal.
More.
You replace this is 1 if then YOB, year of birth. So this more or equal, and then equal 1973. That's it.
It's not bad.
Yeah, and you can check
now you can kind of tabulate, for example, year of birth with your TIO and check. So you can tabulate them together. Now you can do tabulate.
Yeah.
Okay, yeah, that's also fine. You could also like tabulate year of birth and also your new variable.
And like this.
Just type it.
So.
Yeah. You see everyone after 97 is here and everyone before is here, which means that you did it correct. Yeah.
Wow.
Do you know the solution?
I know what?
Like the value, the values?
I checked them today. 24.5. Yes.
Ah, so this is the right one.
Yes, this
Ah,
is the
okay,
right
okay,
one.
okay.
Yeah.
So we were getting different stuff.
No, your is correct. Ah, okay, but probably he created it incorrectly somehow.
So, interaction of these two double variables.
The problem how he created is this.
Expression.
Okay, we just have 2 minutes now. I would probably show
Sorry, yeah,
up to now. And guys, so since the time is kind of going to an end, we will probably continue in the next seminar with this task. Guys, yeah. Let's go quickly through this if you have some questions. First task is you have to generate a variable, t-state, which is equal to 0, for example, and then it can be replaced to 1 if your state is 5. Why state should be 5? Because if you tabulate variable state, then you can see that Nordrhein-Westphalia is state number 5. You can also check yourself by doing this kind of cross tabulation. So, for example, you can do tabulate t-state. What's going on here? Okay, so again, you do this, you generate this variable, and then you have a t-state. Then you generate post variable, and then you replace post equal to 1 if your year of birth is more or less than 1973. ChatGPT can propose a bit different syntax, but in general it's the same. The idea is that you create some group with some condition. In the second case, the condition is that your year of birth is more or higher or equal to 1973, and here the condition is that your state is 5. And then you create a treatment indicator, which is post period times treatment state. So you're interested what happens in the post period in the treatment state. Yeah. So this is a task you. Yeah, it's already defined. So yeah. And then the idea is that you can kind of compare the results and estimate this effort for treatment and control group. So you can run a regression with the build site, which is your outcome variable, and then you include the treatment state, cost, and then treatment, which is the interaction between the treatment state and cost. And so if you run this, you will obtain something like this. And again, your treatment coefficient is 0.24. Yeah. But it's not statistically significant because the value here is 0.15, which is far from the significance level, right? So this means that this coefficient is not statistically significant and there is a null f. And there are t-state captures the initial differences between the states. So this means that in the state NRD, average years of schooling are lower than in the rest of the country.
and then post is the overall time trend, which states that the effect over time is not statistically significant. So there are no statistical significant differences between the states in years of school. Yeah. Any questions? No, not yet. Okay, guys. So we didn't complete this. Maybe the assignment today was too big. We can continue this in the next seminar, and we will also cover the RGD method. I would also recommend you a bit sometimes at home to revise something with data. Otherwise, like if you do it only once in 2 weeks, you are not very proficient in that, right? So it would be nice if you could at least rerun this at home at the day before the seminar, or at this particular day you're waiting for 2 hours for your seminar after the lecture. Why not to just refresh something with data? Yeah. Okay. You file like with answer for no. The idea is like that you
Yeah,
can.
because
We have a questions for task
Okay,
2.
okay.
But I will upload after the next seminar.
Okay, oh,
Yeah.
this is okay.
And the deadline for the submission of our seminar topic, of our paper topic, will be today in 1 week, so the 15th.
15th, yes.
Okay.
But if you do it earlier,
Yeah, better.
it would be also better. And just keep in mind that I think in January 5th you're already presenting something.
Yeah.
On your research project. Yeah?
Yep.
It's like, just look carefully at slide 1. But it's nice that you actually start doing something. Just 1 second. Where is it? Yeah. So January 6th there is a kind of presentation of early proposal and confirm the topic with the structure. I mean, now you decide what exactly you want to study, and in January 6th you have to prepare 1, 2, or 3 slides with an idea. I mean, in general, without too specific, but initial idea, which I will comment, and we will decide if it's doable or not.
Yeah.
We will discuss it on the same. Okay?
Thank you.